That's a great water bottle you got there. Just a guess, but maybe it's looking like 3 centimeters as a radius and 20 centimeters tall.
Wow, Alec, that's exactly right. I just measured it yesterday.
I wonder what the rate of change of the volume is of the water bottle as you're filling up.
I don't know, that's a great question, but I always carry around a ruler. Let's measure it and find out. Well, Alec, it looks like it's increasing at about 3 centimeters a second.
With finding the rate of change of volume of a water bottle when you are filling it up during school hours. So first, we're going to have the volume of a cylinder. Pi r, I can't write like that. Pi r squared h. Definition. Okay, first you have to find the derivative. So we're going to have pi 2 r, that's not right, that's right. Okay, so we're going to have pi times, we're going to use the chain rule in which we have learned many times in class, times 2r dr dt times h plus r squared dh dt. This would be known as the derivative of this equation. Now, we found out that while we were filling up our water bottle, that the radius equals 3, and that the height equals 20.
Mr. Cardwell?
Yes.
What units are those in?
Great question. Centimeters. You know, can you pick up that quarter for us?
Oh, darn you.
Always a jokester, me. Alright, so we found out that it was 20 centimeters, and that the rate of change of the height, so dh dt equals 3 meters per second.
Mr. Cardwell?
Yes.
I think it's centimeters per second.
Gets me every time. Centimeters, does that look right?
That looks good.
Okay. So now, as we take our units and plug them back into the equation, we are left with pi 2 times the radius, 3, times dr dt, which we actually know from our common knowledge that this is equal to 0, times the height, which is 20, plus, now as we put this back in, r equals 3 squared times dh dt, which we look back at our equation and equals 3. So if we work this all out, we're left with pi 2 times 3 is
6.
times 0.
I think that whole side's going to equal 0.
You're getting ahead of me, son. This will be 6 times 0. 0 times 20 does equal 0. Plus 3 squared is 9 times 3. So we're left with pi times 0 plus 27, and so we're left with 27 pi equals dv dt. So at this rate, we see that our water bottle is being filled up at 27 pi centimeters cubed per second. So, in case you're wondering one day in class, when you go outside and fill up your water bottle, how fast is it changing? You'll always remember, even though these may change, we do have an equation to find that.